Welcome to today's ArXiv CS Digest for April 17th, 2026. We received 631 new computer science papers today across 49 subfields. Let's dive into the top picks. Trend 1 of 5, ML Optimization and Adaptation. This trend focuses on improving machine learning model performance and robustness through adaptive strategies and optimized learning processes. This cluster covers 111 papers. Representative work includes benchmarking optimizers for MLPs and tabular deep learning, geometric regularization of autoencoders via observed stochastic dynamics, and beyond distribution sharpening, the importance of task rewards. Trend 2 of 5, Generative Models and Vision. These papers explore advanced generative models for creating, understanding, and manipulating visual data across diverse applications. This cluster covers 166 papers. Representative work includes repurposing 3D generative model for autoregressive layout generation, FineCogNav, integrating fine-grained cognitive modules for zero-shot multimodal UAV navigation, and differential privacy representation geometry for medical image analysis. Trend 3 of 5, ML Model Evaluation and Auditing. This trend unifies research on rigorously evaluating, auditing, and ensuring the performance, reliability, security, and interpretability of ML models. This cluster covers 109 papers. Representative work includes modeling Parkinson's disease progression using longitudinal voice biomarkers, a comparative study of statistical and neural mixed effects models, structural evaluation metrics for SVG generation via leave-one-out analysis, and ASMR bench. Auditing for Sabotage in ML research. Trend 4 of 5, Robotics and Scientific Discovery. Robots and AI accelerate scientific discovery by enabling complex simulations, predictions, and data analysis across diverse fields. This cluster covers 77 papers. Representative work includes verified roadmaps for fixed-time motion planning in continuous semi-static environments, parallelizing the branch and bound with isomorphism pruning algorithm for classifying orthogonal arrays, and OXtratol, an all-atom diffusion model for organic crystal structure prediction. Trend 5 of 5, LLMs, AI Ethics and Applications. This trend explores LLM capabilities, ethical considerations, and practical applications across diverse domains. This cluster covers 168 papers. Representative work includes NiGS2ST, a multi-accent benchmark for speech-to-speech translation in low-resource Nigerian languages. People readily follow personal advice from AI, but it does not improve their well-being, and author-in-the-loop response generation and evaluation, integrating author expertise and intent in responses to peer review. Up next, our first paper out of 5, ASMR Bench, Auditing for Sabotage in ML Research by Eric Ahn and Vivek Heber from Redwood Research. Let's break down its key contributions. The paper introduces ASMR Bench, a novel benchmark comprising 9 milliliters research code bases with sabotage variants. This benchmark is designed to evaluate the detection of subtle flaws in AI-conducted research. Sabotage is implemented by modifying critical implementation details like hyperparameters, training data, or evaluation code. These changes produce qualitatively different experimental results while preserving the high-level methodology. The benchmark is used to evaluate the performance of frontier LLMs and LLM-assisted human auditors in detecting sabotage. This evaluation reveals significant challenges in reliably identifying malicious modifications. LLMs are also tested as autonomous red teamers to generate sabotages. This explores the effectiveness of LLM-generated attacks and their ability to evade same-capability LLM auditors. Up next, our second paper out of 5, CoMeT, Collaborative Memory Transformer for Efficient Long-Context Modeling by Runsong Zhao and Bo Zheng from Northeastern University. Let's break down its key contributions. CoMeT processes arbitrarily long sequences by dividing them into sequential data chunks. This novel architecture enables LLMs to handle extensive context with constant memory usage and linear time complexity, overcoming standard transformer limitations. CoMeT employs a dual memory system to manage context efficiently. It combines a temporary FIFO queue for recent events and a global memory with a gated update rule for capturing long-range dependencies across chunks. The temporary and global memories collaboratively act as a dynamic soft prompt for processing, the next data chunk. This mechanism allows the model to effectively leverage accumulated context without reprocessing past tokens, enhancing long-range understanding. To facilitate efficient fine-tuning on extremely long contexts, CoMeT introduces a novel layer-level pipeline parallelism strategy. This approach optimizes computational resources, making it practical to train models on sequences up to 1M tokens. Up next, our third paper out of 5, Deliberative Searcher, Improving LLM Reliability via Reinforcement Learning with Constraints by Jinyun and Inshun Wang from Fudan University. Let's break down its key contributions. Introduces Deliberative Searcher, a novel framework that integrates certainty calibration with retrieval-based search for open-domain question answering. It enables multi-step reflection and verification over external knowledge. Employs a constrained reinforcement learning algorithm to train the agent, optimizing for accuracy while adhering to a soft reliability constraint. This ensures trustworthy and factually aligned outputs. Focuses on improving the alignment between the model's confidence scores and its factual correctness. This leads to more reliable outputs and enables efficient test time compute strategies. Up next, our fourth paper out of 5, Cloth Hugs, Cloth-Aware Human Gaussian Splatting by Sadia Mubashira and Kevin Desai from University of Texas at San Antonio. Let's break down its key contributions. Cloth Hugs explicitly disentangles body and clothing by representing them with separate Gaussian layers within a shared canonical space. This overcomes limitations of prior methods that struggle with loose garments and complex deformations. A canonical volume jointly encodes body, cloth, and scene primitives. This volume is deformed using SMPL-driven articulation, incorporating learned linear blend skinning weights to animate the disentangled Gaussian layers effectively. To enhance cloth realism, cloth Gaussians are initialized from mesh topology. The method applies physics-inspired constraints, including simulation consistency, ROP regularization, and mass supervision, ensuring realistic and temporally coherent cloth dynamics. A novel depth-aware multi-pass rendering strategy is introduced for robust body cloth scene compositing. This strategy enables efficient and photorealistic real-time rendering at over 60 FPS, improving overall visual quality. Up next, our fifth paper out of 5, GroupDPO, Memory-Efficient Group-Wise Direct Preference Optimization by Jishuan Lung and Inderjit S. Dillon from CMU. Let's break down its key contributions. Introduces a novel memory-efficient group-wise preference optimization algorithm. It preserves gradients while decoupling samples during backpropagation, significantly reducing peak memory usage for scalable training. This contribution focuses on effectively utilizing multiple candidate responses per prompt, moving beyond single positive-negative pairs. It consistently outperforms single-pair training in both offline and online settings. Incorporates a negative log likelihood, NLL, term on positive responses. This addition is critical for achieving performance gains and ensuring robust training stability in the preference optimization process. That's all for today's AR14 CS Daily. If you found this helpful, please leave a comment, and subscribe for daily paper summaries. See you tomorrow.